Hello everybody. Our topic today is three-phase half-wave uncontrolled rectifier. So we're done with the single phase. We took the single phase half-wave controlled rectifier and we applied two loads, which is resistive by itself and then resistive and inductive. And then we studied single phase full wave controlled uncontrolled rectifier. Also, we applied two loads, which is resistive by itself and then resistive and inductive. We're done with single phase. Now our topic is three-phase half wave. So in three-phase half wave, we're going to use three diodes. But before that, we know that three-phase is not single phase; it's three-phase. So three-phase, it's like this. So this is, for example, A. This is B, and this is E, C, and phase shift between each line is 120 degrees. Okay? It's three-phase. So why 120 degrees? Because the total degrees is 360. So 120, 120, 120, that's 360. Okay? So the phase shift between diode 1 and diode 2 is 360. The phase shift between diode 2 and diode 3, the phase shift between diode 1 and diode 2 is 120, and between diode 2 and diode 3 is 120, and between diode 1 and diode 2 is 240, okay? And if you go back, it's negative. You could look at that on page 22. This is in your, by the way, this topic is not covered as a half-wave in your textbook, but we have it in your notes in page 22, 23, and 24. So let's see here what will happen. Okay, so I will have three lines. I will have the first one, the blue, okay. And after 120, the red will be on. And then after 240, the black will be on. Okay? So I can say that this is blue here, diode 1, and diode 2 is red, and diode 3 is black. So let's see what will happen there. The one that we have right here, I'm drawing actually, I will have V source, and I will come up with V out from V source. So this one here is diode 1. This one here is diode 1, okay, or line 1, or I can call it A, which is this, and the other one I'm going to call it B, the red, and the last one will be C. So now let's put the angles. This is 30 here, 60, 90 here, 110, 120, sorry. 150, and this is 180 here, and this is 210, 240, 270, 300, and this is 330, and this is 360. I'm going to draw one cycle, okay? One cycle is enough. Okay, this is one cycle here, and we can call it 1T, okay? That's T. So if I ask you that, if I tell you that one cycle equals 1T, that's what I know. That's what we mean by TT is the time. You will see that in your exams, especially in your labs. Okay, we will ask you to make one cycle equals 1T, or two cycles equals 1T, and so on. Okay, so let's see that B, it will start 120 after, right? So this one starts at 0. This is 0 here. And then B will start at 120. So how to draw that? As I showed you from before, you count 3, and that's your peak. So here, 1, 2, 3. That's my peak. So I go from the peak to 0, and then I go from the peak to 1, 2, 3. So this is B, but I need to finish B here and there. I cannot just leave it like this. So to finish it, You need also to count 3 for the peak. So to count 3, 1, 2, 3. So that's my peak here. Beyond 360. It's okay. I want to draw actually, but I am interested from here. This is my interest. This one just dots. Now I need to finish, so I have to go back. So same thing, I have to count 3, and that's my peak. 1, 2, 3, that's my peak here. Okay. That's my peak. How to finish this? Same thing, you're gonna count 3, and that's your 0. So 1, 2, 3, that's my 0. So like this, and this is dot, but I don't care about the dots, I care about what's between 0 and 360 because I am drawing 1 cycle. I might ask you to draw 2 cycles, so you're gonna draw 2 cycles. So that's B. Now let's draw C, which is the black. And we know that it starts at 240. So that's 120, 240 is right here. Okay? So now same thing, count 3, and that's your peak. Next point is your peak. 1, 2, 3, that's my peak here. So you just draw this. And then I want to finish, so count 3, and that's your 0. 1, 2, 3, that's my 0 here. As I told you, this is making dots because we are not interested in anything behind 360. Now you need to finish this part, which is C. You need to finish it reverse. So you do the same. This is here, this is 0, so you count 3, and that's your peak. 1, 2, 3, that's my peak. Then you count 3 this way, and that's your 0. 1, 2, 3, 0. So here, 1, 2, 3, peak. Then here, now we are on the peak, so we count 3, and that will be our 0. 1, 2, 3, that's 0. Then here, 1, 2, 3, that's my peak. But I am not interested, I am interested out here. See here, I did not touch the peak. This is my peak right there. Okay? Because I know that some students will come and draw up to this point. No, this is the peak here, not here. You need to pay attention to that. Same thing here. Some students will draw the peak there. No, you need to know how to draw. Please, you need to practice how to draw the freeway. Okay? Okay. As we know that this is half wave. Single phase, 3-phase, half wave rectifier. So the pulses that I will see will be 3. The pulses that I will see, only 3 in the positive. Okay? So nothing in the negative since it's half wave. And you are taking only the highest points. The highest points that will appear. Even in your oscilloscope, that's what you will see, only the highest points. So negative is gone. This is V source. Now, okay, if you look at this is V source. This one is V source. So what will be V out? What will be V out? V out, I'll use the green. V out will be, of course, nothing in the negative because it's half wave. Also, you're going to look from the top and you will take only the highest points. The highest will appear, the rest will not appear. So the highest points are this. Now those here are this. That's your highest. And that's your V out. The green is your V out DC here. This one is V out DC. Okay? That's your V out DC. What will be your I out DC? I'm going to use red. I out will be the same. I out will be like this. That will be I out DC. That's for resistive. For inductive, it will be smoother. So for inductive, it will be like this. This one here, current will be smoother when adding inductor. Okay? So the dots with the inductor, and this one here is with resistive load only. And the output is the green, that's the out. So I'll erase this so you already see it. I'll erase this because I don't want you to be confused with the dots. Okay? So this is my current here. Okay, with resistive load only, and with inductive, it will be smooth. You will notice that on your lab. Okay, you will notice that in your lab. I will show you what you will see in your lab. Here, between this point here and this point here, this is alpha for this pulse, and this one here is beta for this pulse, and between this is alpha up to this point here. Okay? So how much is alpha? Alpha equals 30. How much is beta? Beta equals 150. How much is gamma? Gamma equals 150 minus 30 equals 120, and that's 120 right there. This is here, 120. Same thing with this. This will be from here up to here. That's also 120. This will be beta for this, and it will be alpha. This will be beta, and also it will be alpha too for this. 150. This will be here. This will be beta 2. This is here alpha 1, beta 1. Right? For this. This will be same point. Alpha 2, beta. This is beta 2 equals 270. And it will be alpha 3, this one here, alpha 3, which is 270, and this will be also beta 3, because it's one cycle. It's one cycle. Beta 3 is 30. Okay? And gamma will be between this up to here. You can look at page 22. Okay, look at it please, and look at the shifts. Okay. Look at page 23, because I mean, if here in page 23. They explain the I diode 1, I diode 2, I diode 3. Here, in page 23, I diode 1, I diode 2, I diode 3. If I look here, I know that this one here is diode 1. Okay? So, if I want to draw I diode 1, it's 0, then this 0, then all 0. That's I diode 1. If I want to draw I diode 2, which is the red, which is B, this is all 0, and then only this pulse, and then 0. If I want to draw I diode 3, this is 0, because I'm looking for this C. This is 0, this is 0, and this pulse plus this part, which is this. Okay? This is the last one, which is I diode 3, or which is C. And this one here, I diode 2, which is B, and this is I diode 1, which is A. Then the voltage, this is voltage V diode 1, V diode 2, V diode 3. Okay? It will be the opposite. So if you want to measure the voltage across V diode 1, okay? This is here. This is V diode 1, okay? And this one here is V diode 3. So if I draw that, I'm gonna come here. Okay. So V diode 3, V diode 1, let's say V diode 1, V diode 1 means I want to draw the voltage across diode 1. So diode 1 is here, it's conducting. So at this point here to this point here is 0. I know this definitely since my diode is conducting. Okay? Definitely is 0. Here, see, that's on page 23. Definitely is 0. And the rest is this, but it's flipped. Okay? The rest, because we know that this is the source. So now this one here, that's what's left. This one, but in the negative. In the negative. So here you can see it. So I will redraw this. See here. From here, then that's my peak in 2 boxes here. That's my peak, and then that's like this. It's peak, it's 0. Okay, sorry, I think I put the peak longer than it should be. Okay, and then this one here, same thing. My peak is here, so I'm back here. Okay, and then the rest is right here, which is this. That's V diode 1. Okay? And V diode 2 the same. If I want to draw V diode 2, which is this, then definitely this part will be 0 because it conducts, and I will draw the rest. This one here, it will be flipped. This one here, it will be flipped. Let's say I want to draw V diode 3, which is this. V diode 3, okay? V diode 3, let me just draw this line right here. V diode 3, V diode 3. Anyway, if you have problem, issue with the colors, please go back to the notes. It's very clear, and even it's colored. Okay, V diode 3, guys, which is this and this. So I know that it will be 0 here, and it will be 0 here. So I have left this and this. This and this. This is my peak here, and that's my peak here. Okay? So I'll go here, peak, and then I'll go here, then that's peak, then I'll go here, and that's my V diode 3. Yeah, please look at those. Another thing that I want you to look same as before, which are the equations. Equations, guys, please. See here. This in page 24. This table right here is for the equations for three-phase half wave. Three-phase half wave. You will find out that this equation is the same as before. This is the same as before. This is the same as before. The form factor, the P out RMS, Ohm's law, the I out RMS. The difference is the V out RMS and also the V out DC. V out DC. I will explain this equation right now. And this one is I out DC equals V out DC over resistance. That's Ohm's law. But this equation right here, I want you guys to, pay attention to this. The equation right here for three-phase. Let me just erase this. This is V source, as we said. All, and that's the green one is V out diode. Okay, let's look at V out DC equation. V out DC equation, it's 3 square root of 3 V max line to neutral over 2 pi. Guys, you're gonna need this one in your lab manual, okay? You're gonna need this in your lab. Let's go over the lab fast. This is your experiment that you will do for the 3-phase. Okay, so 3 diodes, same, and then you will have the current isolator, and you will have the voltage isolator, and then you will have the load. The load, it will be both resistive. Okay, it will be resistive load, which is 150, and then you will have resistive and inductive. So it will be 150 in series with 0.2, and you have done that before in half wave. Okay, you're gonna do in the chart the first one. We are assuming 124. Then the ripple frequency. Yeah, what will be the ripple frequency right here, guys? It's a very good question. Ripple frequency. Ripple frequency, guys. Here. Ripple frequency for half wave. We had like this half wave, and this is 0. That's one cycle. Okay, 360 here. So I have one pulse. So we say 1 times 60 because our frequency in kingdom is 60. So 60. In full wave, we have 2 pulses. So it will be 2 times 60 equals 120. In our case, how many pulses we have per cycle? We have 1, 2, 3. So our frequency here, in our case, ripple frequency equals 3 times 60 equals 180 hertz. Okay? That's the ripple frequency. And for the common one, which is full wave, 3-phase full wave uncontrolled, we're going to have 6 pulses. And the peak will increase. We're going to have 6 pulses. So it will be 6 times, that's for the diodes, but for the phase, it will be 3. Okay? Let me erase this, because this one here, I think, I don't know if I explained it in half wave in lab, but I explained it in full wave. Anyway, so that's the ripple frequency. What you will do in lab, you're gonna apply resistive load, and you're gonna fill this, and the conduction angle will be 120 here. Conduction angle will be 120, and same thing with the inductive. Okay, it will be the same, all the same values. And you're gonna draw here. That's the V source. And this is the V out DC. See here, this is 1 cycle up to 360. We have 3 poles, and that's the drawing is for 2 cycles. And that's the current for resistive load, and that's the current for inductive. The only difference that the current for the inductive is smoother than that. What I have done to draw this, I use a pencil here. You see the pencil right here. Then I erase. I left only the V out DC. I use a pencil to draw all those lines. Okay, the 3 lines with the phase shifts, and then I erase everything. This is your. But there will be questions asking you guys and to answer, which is in page 21. You need this equation. How we get this equation? See here, we have line and neutral. Line, neutral. And the connection. In the full wave, which we will do next time, we're going to have line to line. So the equation will change. Let's see here. So here, I have how to get this equation. 3. That's because I have 3 diodes. Okay? And this one here, this connection right here, it should be Vmax, line to line. Since we have line to neutral, we know that this one equals this, right? Over 2 pi, which is the cycle, okay? So that's our equation for 3-phase half wave uncontrolled. When we do the 3-phase full wave, which we will have no neutral, and we will have 6 diodes, okay? So what will change? This one now, this is for 3-phase half wave. Okay, but here now, V out DC equals this one here for 3-phase full wave. Okay, this is this, and this is this. I will have, instead of 3 diodes, I will have 6 diodes. This equation not for next experiment, for the experiment after. I will have 6 diodes, okay? And I will not have square root of 3 because I will have Vmax because the connection is line to line. So Vmax line to line, and I will have 2 pi. So I will cancel the 2 with the 6. So I will end up with V out DC equals 3 Vmax line to line. This equation here is for full wave, and this equation here is for that. Just to know that I explained this, so you guys know this. Okay? So this is the equation. This is the V out DC for the half wave 3-phase uncontrolled rectifier. Okay, here I might explain, this is here, which is the multi-phase system on page 25 and 26 and 27. Multi-phase means we can use more than 3, 4, 5, 6, 7, 8. So we can connect neutral, and also we can add as much as we can of diodes. The more diodes we have, the more ripples we get, means the smoother the voltage we will get. Okay, so here that's a good example for 10 diodes. Okay, and this is a very good calculation for the waves. So look at it, please. Okay, look at the multi-phase system. And those are the equations for the multi-phase, and then the topic after is 3-phase full wave. Okay, so what I want you to read in page 26 for half wave, page 22. Please look at page 22 to 26 notes. As I told you, this topic is not covered in your textbook. Full wave is covered in your textbook. Make sure you watch this before your experiment, and look at your manual before you come to lab, because we will have no introduction in lab. You will go directly to do your experiments, and see you next time.